Right, good morning, Year 9. So what we're going to look at today is nuclear power. But last lesson, just to remind you, we looked at all the different kinds of renewable energy sources there are out there. So basically the ways that we can generate electricity from renewables. First question I'd like to answer is, what has the quickest startup time? What I mean by that is, which method of generating electricity are we able to just switch on like that really quickly? So, do you think it is coal, oil, gas, or nuclear? Okay, so pause the video quickly first and then write your answer and which one you think it is and why. Off you go. So, of these three, the one which has the fastest startup time is gas. You simply flood the gas through the system, ignite it, and it starts to heat the water very quickly. Coal and oil can take quite a long time, and nuclear takes the longest. That can take several hours to get a nuclear reactor generating enough heat in order for it to turn water into steam to generate electricity. So, why bother using it? Well, it does have its uses, and that's what we're going to look at today. However, the one with the quickest startup time overall is actually this one, which you looked at last week, which is hydroelectric. And what happens is you simply open the floodgate and the water floods down, turns a turbine. And the reason we need this kind of thing is because often in electricity there are spikes in demand, times of the day when more and more people are using electricity, and we need to be able to turn electricity on and off really, really quickly. Okay, and so actually hydroelectric and gas are very, very good at meeting these very sudden spikes in demand. Okay, but today we are going to look at nuclear power. So that is your title for today. So, nuclear power. Once again, can you pause the video and write down what do you think we mean by nuclear power? Okay, so some of you might associate nuclear power with radiations and mutations, or nuclear weapons, or radioactivity, sort of quite dangerous thing. Okay, and that is potentially all true. However, it's not the be all and end all. So what we're going to do today is we're going to look at how or what happens in a nuclear reactor. Hopefully, most of you will be able to explain the pros and cons of nuclear power because there are good and bad points, and a few of you evaluate the effect that Chernobyl had on local people. Right, the first thing I would like you to do is I would like you to copy up this diagram. Okay, now that will probably take you about 5 minutes. Copy that into your book and then I'm going to explain it to you. So pause the video now and copy that into your book, please. Okay, now don't worry if you're not completely understanding this. We're going to go into this in a lot more detail in year 10. But essentially what happens is this is a nuclear reactor, and there's a close-up of it here, so let's have a closer look. What you have are these uranium fuel rods. Okay, these contain a material called uranium, and what happens is they get really, really hot, and they heat this material, which is here shown in this sort of beige color. It's usually a gas, usually carbon dioxide, or sometimes water. Okay, and this heated material, or coolant as it's known, will come shooting out of this tube here. So we're going to follow it here. So basically, these uranium fuel rods here and here make this material, usually a gas, really hot. It comes out here, and as this heated material flows over these tubes, what happens is they heat the water inside. So water is coming through these tubes like that. And as the heated material goes over these tubes, it heats the water and turns it into steam. Now you'll notice that the coolant doesn't actually touch the water, it doesn't mix with the water. What happens is the heat energy passes from this heated gas through the tubes and heats the water that way. So the water is then turned into steam. Okay, and steam, as you know from the last couple of lessons, can be used to run a turbine which generates electricity. Okay, so hopefully that gives you some idea about how this works. Okay, so it might be a good idea to once again just pause the tape and very quickly explain it in your own words. Okay, so uranium heats the coolant goes out through the tube and heats the water, turns water into steam. Now remember, steam has a lot of kinetic energy. Okay, so essentially you're taking the heat energy from here, transferring it to kinetic energy in the steam, and then the steam will the kinetic energy can be transferred to electrical energy. Okay. Now, you have a few other things in a nuclear reactor. You have also things called control rods, and these control the reaction. Basically, you put these down in between the fuel rods like this, and what will happen is that will stop the reaction. Okay. Also, because nuclear materials like uranium are very, very dangerous, very radioactive, they all need to be contained within a steel container, what we call a reactor, which is then also surrounded by a concrete core. Okay? Right, so what's happening in a nuclear reactor? Well, I can actually explain it with this diagram. So this is a nucleus of a uranium atom, and this is what you find in the fuel rods. So what happens is something called a neutron, which some of you will know as part of an atom, gets fired at a uranium nucleus. Now what happens is that makes it unstable and it splits. Okay, and it splits into a couple of things. What happens is it splits into what we call daughter nuclei, krypton and barium, but you don't need to know too much about that. And as it does, it releases a huge amount of energy. So we'll just do zzz there. That's basically your heat energy just coming out. It's actually sort of radiation, but it's heat energy coming out. But it also does something else. Okay, it also releases some extra neutrons. So there, and there. Now, what that means is these neutrons can then go on and do something rather strange. Okay, what they will do is they will then go on and hit other uranium nucleuses like this. And so what will happen is they will then split and give off more neutrons themselves. And so this whole process continues like that. It's what we call a chain reaction, and every time they split, sorry, I should really say, they give off some energy, which is the heat. There it goes, and that heat is used to heat the coolant up. So this is called a controlled chain reaction. Now, you're not going to learn about this properly until year 10, but it might be useful to have that in your book. Okay, so this is a controlled chain reaction, and what happens is neutrons, so let's just label a few things up here. Neutrons are fired at a uranium nucleus. Okay, and what will then happen is that uranium nucleus will split and release its energy. Okay, and in doing so, it releases 1, 2, 3 extra neutrons. And let's just put energy over here. Okay, and those neutrons will then go off and set off other uranium nucleus, and the whole process just carries on and on and on and on like that. So pause the video and please copy this into your book, and you only need 1 or 2 sentences to explain this. Off you go, please. Right, so these are some key questions about nuclear energy. These are actually in the exercise books, but we don't have those, so I'm just going to talk you through these. What is uranium? Right, uranium is the radioactive fuel which basically powers a nuclear power station. What is nuclear fission? Right, fission is basically a fancy word for splitting. That is nuclear fission, when a uranium nucleus splits and gives off neutrons and daughter nuclei like that. What is given out when a nuclear fission happens, and how does this make electricity? Okay, so what's given out are neutrons, but also energy, and that heat energy can be used to turn water into steam because the heat energy heats the coolant, and then that heat turns water into steam, and then that's kinetic energy of the steam can generate electricity. How does the startup time compare to fossil fuels? Oh, sorry, question 4. What impact does nuclear power have on the environment? Right, well, if all goes well, very little. It doesn't give off any carbon dioxide, which is the real benefit because it doesn't therefore contribute to global warming. How does the startup time compare to fossil fuels? Bad. It takes hours for these things to get up to speed. Okay, so really we can only use nuclear power to generate electricity for things that kind of need to be on all the time. Okay, so it's there in the background. It's what we call providing base load. It basically gives you the electricity that you need in the national grid all the time. But if there's ever a spike in demand and we need electricity quickly, nuclear power would be rubbish at meeting that demand because it takes hours for it to heat up. How much energy per kilo of fuel is produced from nuclear power compared to fossil fuels? Right, unfortunately that exact amount is in your books. Don't worry too much about it. What I will tell you is it's more. What I mean by that is 1 kilogram of uranium can produce loads more electricity than 1 kilogram of coal. Okay, so if you had a kilogram of each, okay, you'd get loads more energy from nuclear power. Right, time to set you about your task. So, in assignment, and also I placed this in on the chat board. Okay, you will have this assignment. Okay, now we're going to have to do it slightly differently from how we were going to do it in class because we were going to do it as a class debate, but you should be able to log on and see this. Okay, imagine that the UK was planning on building nuclear power stations in order to meet its demand for electricity. Okay, so imagine we're trying to build 10 nuclear power stations. What if one of these was built near you? Okay, so what I want you to do is read through the information in assignments, and some of the information cards are not relevant, so you need to decide which points you are going to use. So, using the information, decide if you would want a nuclear power station built near Shepperton. Consider the evidence and lay out the points for and against such a project, and then come to an overall conclusion. So this should take about a page in your book to outline and explain your arguments. Right, so there's a bit of information, and then there's about 5 pages, I believe, of argument cards. These are points which both say give the good points about nuclear power stations and also the bad points. What I want you to do is summarize some of these points and then make a reasoned and cogent argument as to whether or not you would want a nuclear power station built near Shepperton. Okay, so whatever points you decide to use, explain those, make sure they make sense, back them up. Okay, you can use supporting evidence because some of the cards do support each other. This should take at least a page in your book, probably slightly more, in order to explain your arguments. Okay, so once you've looked through all the cards and then written your page, that will probably take you most of this lesson, probably about 40 minutes or so, in order to do that properly. Then there is one last slide I would like you to watch, which has a video link to what happens when it goes wrong. Okay, so some of you might be familiar with this place, Chernobyl. Okay, this is what happens when nuclear power goes wrong, and I will put this link next to the link of this tutorial, but probably not a good idea to watch this until the end. Okay, so what I would like you to do is once you've finished, please upload your arguments to assignment and I will mark them next week. So I will be checking. Good luck.